Hello everyone, this is Jianli Chen. I'm a PhD candidate at School of Building Construction at Georgia Tech. So in this video, I will briefly introduce all the contents in my posters. The topic of this poster is the investigation of the high bridge ventilation potential of commercial buildings in US. So I will start with the introduction. The first, what is high bridge ventilation? So it's a ventilation strategy that couples the mechanical ventilation with the natural ventilation, so that they can switch the modes between each others, and it's also called mixed mode ventilation. Then its the objective of this study are mainly twofold. For the first place, we want to investigate the difference between the uncertainty analysis and the deterministic simulation to help a more robust design of a building with natural ventilation. While then second, the main aim of this study is to more thoroughly quantify the high bridge ventilation potential across US, considering all these three aspects: the uncertainties, the different intelligent building controls, and also the influence of outdoor air qualities. These three aspects are typically neglected in the current study. So these are the research overviews. The research will be mainly composed of two parts. The part one is the using the uncertainty analysis to better uncover the thermal comfort risks, while the second one is the true potential investigation. So then we come into our uncertainty analysis part. Uncertainty analysis is the technique that provides a probabilistic probe into our interested variables, and it's composed of two steps. The first is the uncertainty quantification, it's UQ. So in our study, we consider mainly four aspects of uncertainties, while then the second step is the uncertainty propagation. So in our study, we use the GRAW-W, which is short for the Georgia Tech Uncertainty Analysis and Risk Analysis Workbench. Then for the sensitivity analysis, we use the MAS approach, which is a meta-model-based approach. Then these are the comparison between the uncertainty analysis and the deterministic simulation. And this graph is very interesting. It shows that the deterministic simulation result actually falls on the far left end of the uncertainty analysis result. And it means that the deterministic simulation could potentially neglect large thermal comfort risks. While then we also conduct the design scenario test. Here we investigate 4 design options and then come up with the rule of thumb for the designers to help them design a building with better natural ventilation performance. Then we use the uncertainty analysis to identify the 4 most important uncertainties that will be applied in our later investigation. And we also develop our intelligent control, which is the model predictive control based on 3 clusters of neural networks. We present our intelligent control levels here, and also we quantify the influence of outdoor air pollutants on the indoor air pollutants during natural ventilation by collecting the data from EPA website. Here, I just list part of the potential investigation results for 4 representative cities. If we consider the outdoor meteorologic only, the conclusion is that Los Angeles is the most suitable climate for the hybrid potential, for the hybrid ventilation, while then come with the San Francisco. And for the rest of US, like Seattle, like Atlanta, and also the other big cities and the corresponding climate zones, they share a similar energy saving potential, which is actually approximately 15% to 25%. And these are the histograms associated with this table. But if we consider the influence of outdoor air pollutants, you could see that the Los Angeles original can save maybe up to 70% of the energies. But because of the outdoor air pollutants, actually 90% of this potential could be gone. And then the San Francisco became the best city for the hybrid ventilation usage. Also, the other very important conclusion is that the influence of the building intelligence level on the hybrid ventilation usage is very significant. It can lead to up to 15% of the difference of energy savings. So I definitely have more results, but the time is limited. So I will stop here, and these are pretty much everything on these posters. And thank you for taking time to going through this.